Section 5.1. Yesterday we talked about what was. I'll just do this real quick. What was the thing we talked about yesterday? If that was, yeah. So that was the bisector, right? And then went like this, right? So it wasn't just a bisector. What was it? Perpendicular bisector, right? So if that's perpendicular, and if that is equal to that, right? That's a perpendicular bisector. Agreed?
Agreed.
Right. And we did a triangle, and we said if you took the perpendicular bisector of all three sides of the triangle, they all meet at one point. They're concurrent, right? Which means they all meet at one point. And we called that point something, what was it? The circumcenter. And we said that circumcenter is what to the vertices of the triangle? They were equidistant. That's right. They were equidistant from the three vertices of the triangle. Remember all that stuff? All right. I won't rehash all that in detail, but just kind of get it in your mind. I mean, you did homework on it last night, right? So you should be familiar with it. Okay. Let's talk about something else. Instead of talking about a perpendicular bisector, this time we're going to take an angle. Okay, there's an angle right there. And what we're going to do, let's do this. We're going to actually bisect the angle. Now again, I've got to eyeball this a little bit. So you're going to have to tell me if that looks like it bisects the angle. Does that look like it splits that big angle into two equal angles? Maybe about like that? It's pretty close. That's pretty close. All right? Doesn't have to be perfect. That's okay. I think we're fine now. So watch this thing right here. Let's put some, let's label this. We'll call this B. And we'll just stick a point here. We'll call it F. I'm not going to label anything else right now. So BF bisects this big angle right here. Everybody see that? So if it bisects it, what must be true? That little angle equals that little angle right there. Okay? So you know that already, right? You know that because the definition of bisector says it splits an angle into two equal angles. Well, here's the thing that's new today. And let's change colors. Let's change to a nice blue. I don't know if you'll be able to see the difference or not. I don't know if you hit the hit the light. Can you guys see? Okay, turn the light out.
Oh yeah,
You're not gonna fall asleep on me, are you?
Cool.
Okay, so it looks a little bit better up there, doesn't it, with the lights out? Okay, so watch this. This point right here. This is just any point on the bisector. You follow me?
Mm-hmm.
So let's get rid of that thing. All right, so this is any point on this bisector. I could have put the point here. I could have put it way out here. I could have put it real close to here if I wanted to. I don't know. I just figured I'd just stick it right here. Now, if this is on an angle bisector, our theorem says this. We have a theorem that says that point is equidistant from the two sides. I almost said three. From the two sides of the angle. All right. So what do we talk about is when we talked about distance. Remember, we said if you have a point and you have a line not on, or a point not on a line, what is the distance? How do we describe the distance from that point to that line? It's what? So if I had a line and I had a point, how do I describe the distance from this point to this line? Right, perpendicular. Remember that? All right, so that's pretty important. So it has to be perpendicular. Agreed?
Agreed.
All right, so let's think about this. Here's a point not on this line down here, correct? If I wanted to find the distance from this point to that bottom side of the angle, what am I going to do? Am I going to take it out to here? Am I going to take it to here? Stop me. About right in there somewhere. Okay. No, that's perfect right there. Okay. So right there, that's the distance. That little blue segment right there, that's the distance from this point to this side of the angle. And we'll label that. We'll call that E.
Are those really congruent, or did you just eyeball it? Those
What, these two? I eyeballed
That's
that.
what I thought.
Yeah, I eyeballed this, okay? But if that was, now look, if you had a protractor,
Exactly.
I bet you there's probably some kind of online protractor. I'll have to look for
There
one
are.
that I could actually put on here and I could see through it. I just got to find one. I haven't really looked, but I bet you there is one. But I'm not. We're just eyeballing it, okay? We're just looking at it and guessing, educated guess where it is. Now watch. What did I just say? It's equidistant from the two sides. So if that's perpendicular, what am I going to do? Come over here, perpendicular. Tell me when it looks perpendicular. About like that. It's pretty
A
close.
little bit.
All right,
It
so
looks a little
watch.
bigger, a little longer,
That's
but
pretty.
it's close.
Yeah. All right, so watch. If this lies on the perpendicular, or I'm sorry, on the angle bisector, guess what? The distances from the two sides of the angle are equal. So that and that will be equal to each other. Right? That's what our theorem says. Okay, that's something that we hadn't learned before that we learned today. So again, we're on an angle bisector. Any point on the angle bisector is equidistant from the sides of the angle.
Does that mean the triangles are congruent?
I don't know. Does it?
I think it does.
Give me a reason why.
Angle,
Side,
angle,
angle,
side.
side.
Angle side. Or you could say, well, you could say a couple different things. Because look, if these two angles are equal, then that's the third angle theorem, right? So those have to be. So you could say angle side angle, right? Or you could say angle angle side, couldn't you? Or that too. You could say angle side angle because of this one, right? And you couldn't say side side. No, you couldn't say side side side.
Did you say side, angle, side, because that side?
Yeah, you could go side angle side. Good. You could go side angle side as well. Yep. So there's all kinds of ways. All right. There's all kinds of ways, except for side side side. You couldn't use side side side. No. You can't say that this is equal to this. That's D, right? Oops, that doesn't look like a D. There. Now you can't say this is equal to this until you've proven the triangle's congruent. If you've proven the triangle's congruent, then can you say BD equals BE?
Yeah.
Yeah, for what reason? Right, that's right, the corresponding parts, CPCTC. All right, you got it? All right, so anyway, that was a good question. They didn't ask that question in the other class. So that was a good question.
They heard that.
And they would be. No, they because I'll have like 2 people that actually watch the other class, and they're definitely not going to come to your class and watch it, so I'm not worried about that. Okay, well, same thing with you guys. You don't go to the other class and look at it. All right, here we go. So that's that. That's called the angle bisector theorem. How about that? It's not very ingenious, is it?
You
But
should make them cool names. Like, these names are so boring.
no, these names are great because they describe. Yeah, they're easy. They describe. If you made some crazy name, you're like, why do they call it that? I'll never remember that.
Last
So
year,
they call it something that you can remember. So they call it the angle bisector theorem.
last year we had the
In
new
the
Pop
book,
Tart.
there's like when you would do some of the problems, they weren't the ones that we were doing, but they were on the other page. It's like use theorem 5.2.
Yeah, see, that's dumb. See, if you learned it like that, I know teachers, well, I know of teachers that have done that in their geometry classes. They make them memorize the theorems by the numbers, and they'll have a quiz and a test, and they'll say, you know, what's theorem 4.7 say? And you have to recite it word for word, and it's ridiculous. There's no way that they should make you do that because that's just right. It's just memorization. I'm trying to get you to learn how to do it. I want you to understand what the words mean, but I also want you to understand how to do the stuff. And just rote memorization, it does not help you, okay? And plus, you learn theorem 4.7 in this book. If you look at another book, that theorem is not necessarily going to be theorem 4.7, okay? So there's no reason to remember these by the numbers because they're not. It's not a universal code or anything, right, for these theorem numbers. Does that make sense? Okay, enough of that. So basically, this says this. Let me write this down. It says if ray BF, okay, I'll say this, bisects angle what? DBE? All right, then, so I'm going to write it as an if-then statement. You've seen if-then statements quite a bit so far this year. I'm sorry. Let's not do the then yet. All right, if BF bisects this, okay, and if, let's see, FD is perpendicular to BD, and what? FE is perpendicular to, what's this one? BE? All right, there we go. If all that stuff's true, all right, if this BF is a bisector, if this line segment right here is perpendicular, right? These two are perpendicular and these two are perpendicular, basically, right? If all that stuff is true, then what can you say about the lengths of these two segments?
They're equal.
They're going to be equal. All right, so DF must equal what? EF. You get it? So
Yeah.
that's a lot of ifs, isn't it? All right. If this is a perpendicular bisector, I'm sorry, I keep saying perpendicular because that's what we did yesterday. If this is an angle bisector, and at this point F right here, this FD is perpendicular to this side, and FE is perpendicular to this side. If that stuff is true, then guess what must be true about the lengths of DF and EF? They got to be the same. All right. They have to be equal to each other. You get it?
Got it? Get it? Good.
Look, this is not the first time we've done this. We've done this a whole bunch of times. What do you think comes next? We have an if-then statement, and a lot of these theorems, not every theorem, but we do what? Somebody almost said it. I heard the converse, right? The converse of it. So let's think of what the converse says. Let's get rid of a few things here. Let's get rid of some stuff that was... Let's get rid of that. Let's get rid of this stuff right here. Yeah, let's get rid of that. We'll keep that. We'll get rid of this. Okay? All right. So now, I'm going to keep this up here, but that's the angle bisector theorem. Let's do this in black so it looks a little bit different. So now what I'm going to do, since I've written that there, I'll write this down here. The converse of the what? Angle bisector theorem. All right, so now we're doing the converse. Remember, the converse does what to the if and then? Just changes, right? Flips them, okay? So watch. Instead of saying if all that stuff is true, then DF equals EF, what could we say? If what? Right, if DF equals EF,
Then blah, blah,
then blah, blah, blah. Right, all that stuff is true. Then BF bisects, I'll write it all out, bisects angle DBE. And what else? FD is going to be perpendicular to BD. And what? FE is going to be perpendicular to BE. All right. So let's think of what we start with. What do we start? It says if DF is equal to EF. So if I'm given that this and this are equal to each other, and that's all I'm given. All right. I'm given a line. I don't know it's an angle bisector yet, do I? I'm just given a line that goes through this angle somewhere. I've got a point here. If I'm told that this segment and this segment are equal to each other, I can now tell you about three different things, couldn't I? I can tell you what? That that's perpendicular, and that's perpendicular, and what else? That BF must be the what? Angle bisector, okay? Or I could say that this angle equals that angle, okay? So what's given? What's given is in the blue. Right? What can I conclude then? If I'm given that DF and EF are equal to each other, I can conclude that, all right, well, that must mean if these two are equal and it lies on this line, then this must be perpendicular, these two, and it lies on a...
Oh.
It's always looked like a pencil.
No, the drawing.
Oh, the drawing looks like a pencil?
Yeah, because your little angles look like a pencil. Looks like the tip.
See how
See
it's
that?
like that part?
Like this? Like that's the tip of the pencil?
Yeah, yeah.
Oh, okay, yeah, I get it, because it's kind of like three-dimensional, like that's one of the edges. I get it, okay. Well, anyway, no, we're not going to, just to make it look like a pencil. So watch, these two angles must be equal to each other. Go ahead.
Wouldn't it, the converse be that the angles have to already be perpendicular? Because if you had a giant angle and then a line inside it that wasn't bisecting it, that was like all off.
No, it wouldn't be off. If the two are perpendicular, if the two things are equal to each other, it must be perpendicular. So, for instance, watch. If I did this, if I said, like that, oops, hold on. What am I trying to do? Look, I took that out like this, and I took this. Yes, I do. Whoopsie daisy, I don't want to do that.
Whoopsie daisy.
Shh. What am I doing? I don't know. Say it again in 10 seconds.
If the bisector wasn't bisecting it and it was off center, then could you have one be like farther down?
No, yeah, then they wouldn't be equal to each other. So it's saying if they're equal to each other, then all that has to be true. All right, I got to stop.
Bye. Love you guys.
Be free.
Bye.